Hello, and welcome to Coding Bootcamp's Introduction to the Python Programming Language. I'm your instructor, Stephen Elmeroth, the founder of PrimeSite, a small tech company. We deliver web systems. I've worked for large and small startups, and doing mostly Java, PHP, Python, and JavaScript. And recently for Scraping Hub, writing spiders for the big name brands. This is an introductory course, so there's no prerequisites. But before we get started, let's just view the outline. So this will be a 10-part series. This is part 1, Introduction to Python 3. Okay. This video is for those with a basic understanding of programming. And to get the full advantage of the course, it's good to have some prior scripting knowledge. So let's get into the objectives of this course. We're going to talk about the origin and goals of Python, the overview of its features, how to get and install it, how to access the documentation, talk about PEPs, talk about Python's strengths, and we'll talk about how to use Python with other programming languages. Alright, so Python originated around 1989, created by Guido van Rossum, the benevolent dictator for life, as he is known, or was known at least. And at the time, he was working for the National Research Institute for Math and Computer Science in the Netherlands. And he released version 1, November 1994. And nobody really talks about Python 1. The only Python people really talk about, well, up until recently, Python 3 is being used, but really Python 2, everybody used Python 2 after 2000, and currently Python 2 is at 2.7, and Python 3 is already at 3.8, the 8th version of Python, and people still download and install Python 2. So there was a big jump between Python 2 and Python 3. People said Guido did Python 3 wrong. He introduced it wrong. Or the reason that I liked Python 3 over Python 2 was that he didn't do what PHP did, which was carry over all the legacy code and make it backward compatible to previous versions of PHP. There was some problems with Python 2, and instead of carrying that baggage around, Guido said, let's just get rid of it and, start with a fresher version. So he sort of got rid of some of the backwards compatibility, which is what major version releases are. They're not backward compatible. So there was a slow adoption for Python 3. And the biggest, I guess, of the reasons that they fixed in Python 3 was Unicode support. Python 3 has full Unicode support. And the other change that people know about was the print statement was changed to a print function. So you needed to use parentheses with your Python. We'll cover that in the video. So Guido's goals with Python were to make it easy and intuitive, and just as powerful as the major competitors of the time, like ASCII, or Perl, perhaps. It's open source, so anyone can contribute to its development, in theory. The code is understandable as plain English. As we'll see, it reads very nice, very beautiful, with its indentation. And it's also suitable for everyday tasks, allowing for short development times. So let's talk about Python's features in the next couple slides. All right, it's simple. It's a simple and minimalistic language. So reading a good Python program feels almost like reading English. The pseudocode nature of Python is one of its greatest strengths. It allows you to concentrate on the solution of the problem rather than the syntax. So, as Guido says, Python is read far more often than it is written. It's also easy to learn. Python has few keywords, simple structure, and a clearly defined syntax. It's free and open source. In simple terms, you could freely distribute copies of the software, read the software source code, and make changes to it. Depending on the license, of course. It has a high-level language. It's not a low-level language. It's a high-level language. So when you write programs in Python, you never need to bother about low-level details such as managing memory used by your program, like C++. It's portable. Python can run on a wide variety of hardware platforms. It has the same interface on all platforms. Interpreted. It's not compiled, it's interpreted. No separate compilation and execution steps. The program is run from the source code. So that can make things a little bit slower, but more portable. You don't need, and by more portable I mean you don't need a virtual machine. You can just run it anywhere you have an interpreter. Object-oriented. In object-oriented language, the program is built around objects which combine data and functionality. Python has a very powerful but simple way of doing object-oriented programming, especially when you compare it to languages like C++ or Java. It's also scalable. Python provides a better structure and support for large programs than shell scripting, for example, or Perl for that matter. Extensive libraries. The standard library is huge. Some say to its fault. It can help you do various things involving regular expressions, documentation. Many things are packaged in the standard library. But also there are many third-party libraries written. Many third-party libraries. It's interactive mode. Python has support for interactive mode, which allows interactive testing and debugging of snippets. We're going to look at that in the terminal. Getting and installing Python. All right, let's find out how to get it installed. So you open a terminal, and you go to Downloads, install the latest version by clicking on the download button, and then you save the MSI package and run the installer. Select the defaults and select yes to disable the path limit. We're done. That is for Windows. Now let's take a look at what it might look like if we were running, for example, Linux. So let's go to Downloads, click the big yellow button to download the latest version, and it is going to download an XZ compressed file, just like zipped file. You don't have to be able to read that, it's just giving you an idea of the basic functionality. So let's have a look at what that might have downloaded for us. So let's go to Downloads. And we can extract it to its folder. Let's go into the folder. And we can look at the README file. If I could type, of course. So what do we do? How do we use this? What do? We downloaded a bunch of source files, and now we are going to have to compile them. So first we get to the command line, run configure, then make, and make test. So we could try that if we wanted to, I suppose. It's right, we have a configure file. And it's going to check for if we have our compiler installed, and make sure we have the ability to make it. This will also generate a make file for us, but it takes a long time to compile depending on your processor, how fast it is. It's going to take a little while, so it's not quite as... Okay, see, we can run make test. First we have to run make, I suppose. We want to build it. So it's going to compile all the modules. But we'll let that run in the background. Now, back to the show. Accessing Python documentation. All right, pretty simple. You go to python.org/doc. Yeah, let's look at that. Python docs. Let's click on the big yellow button just like we did for download. See what we get. What's new? Tutorial, library reference. And the main thing we want to look at is probably the API. So maybe that's under language reference. The import system. Right. The ecosystem is huge. There's a lot to see there. Alright, so what are PEPs? Python Enhancement Proposals. A PEP is a design document providing information to the Python community. So you create a PEP. If you have a new idea for Python, you create an enhancement proposal. You want to enhance Python, so you create a proposal. For example, moving from Python 2 to Python 3, we went, somebody found a problem with the print statement being a statement. And now you can see print statement now needs parentheses. Before it didn't have parentheses, but now it's a function, so it needs parentheses. So somebody had to write the PEP for that. Let's see if we can search for that. Python PEP print. Oh, our make is finished. Now we can make test. And it'll test to make sure they're compiled okay. So here we have PEP 3105. Make print a function. So this was done by George Brandl in 2006. So he gave all of this. The title says it all. This PEP proposes a new print built-in that replaces the print statement and suggests a specific signature. Okay. So you can read about all the other PEPs here. PEP index, PEP 0, and I guess one of the big ones is, let's see, is it 8? Somehow, PEP 8? PEP 8? PEP 8 is the one PEP maybe everybody should know. What? PEP 8 can't find PEP 8. I think it's 000008. Right? So it's probably 00008. It was 2001. One of the first things Guido did. This is, yeah, Guido wrote it. So he talks about style guide, you know, standards. You can see it's a pretty long document talking about what to do, what to not. So this is the wrong way to do indenting, operator indenting. And this is the right way to do it, according to PEP 8. All right, let's get back into it. Python's strengths. Its readability and simplicity. Like Guido said, it's read more often than it's written. So it's easy to understand code written in Python. Development time. Python programs can be developed 3 to 5 times faster than Java programs. Libraries. Easy to use libraries in Python. Just install and import. User community has a huge and supportive user community. All over Google as well. So just search and find the answer. And our compile failed. Make failure. Compression requires missing. Okay, so I need to install zlib module. So, see, it's not so easy on Linux. Although, if the download would have had precompiled versions, which they apparently don't. Huh. I have to check that, but there are installing things on Linux is not always necessarily that difficult. Okay, back to it. The user community is big. Now, using Python with other languages. Let's wrap up with this. Python can be used with other languages. The Python C API, which is a C library that helps to embed Python modules into C++ programs. It's built and distributed with Python. Now, IronPython is an open source implementation of the Python programming language, which is tightly integrated with the .NET framework. And Jython is also an implementation that lets you run it in JVM. So, for example, Jython is written in Java, and it specs out the maybe 100% Python API. So you can use Python code and run it in JVM. And why would you want to do that? Maybe because you have other code written in Java that you want to access. This would make it easier. Maybe you want to access Swing or create some user interface with Java's screen programming libraries. All right. An assignment. Install the latest version of Python 3 and an IDE, an integrated development environment. All right, so wrapping up the live coaching sessions for Python available at the following URLs. You can see those on the webpage. There will be a follow-up class to this. Object-oriented programming examples for Python. You'll also be able to see some other training for this platform. The next session, we're going to talk about using Python. So this was an introduction, and we will then, on the next session, see you for using Python. Okay, thank you very much.